All right, here we are back into the spectrum analyzer. This is an HP 3585B spectrum analyzer, and this is going to be part 4. Thought the series was over, but seems we're going to have a little more a look into this analyzer. Still looking at ideas for replacing the BNC. So I was planning on taking the front end module out anyway and have another look to see about options for replacing the BNC connector. And shortly after I posted the third part of this series onto YouTube, one of the viewers pointed out a potential component problem inside the front end section. So we're going to take this out and have a look. I reviewed the video, and to me it also looks suspicious. And it's kind of funny how sometimes things are right there in front of you, but you don't see them until somebody else points it out. So we're going to take a look at that. And what we're going to do is take this module back out and have another look at the potential problem here with some more damaged components. All right, so we got the ohm meter hooked up here, and all of this unit's powered down. We'll just disconnect it from the line cord here. And the first thing we'll do is we'll go ahead and isolate. So this plug here is for the power input to the front end module. And we'll just take a quick resistance here across each of these input capacitors. So we'll check the positive, which is the plus 15 volts rail here to ground. And we've got a reading of about 2.6 kilo ohms. And we'll take a reading here from on the negative rail, and it's reading 427 ohms. So significantly different than the resistance from the positive rail, the positive 15 volt rail. If you just do just a quick Ohm's law calculation, if you say 15 volts in across 430 ohms, gives you about 30 some odd milliamps. So it's not an incredibly high current draw, but it is different than the positive rail. So it's just something to note. All right, and here we are back inside the front end section of this HP 3585B spectrum analyzer. And so the component in question is this component right here, and it is indeed damaged. So what is that component? Well, that is supposed to look like this one right here. It's a tantalum capacitor, and particularly it is this component right here, C123. So let's see, what is C123? Let's see where that is in the power supplies section, which is here. So C123 is a 2.2 microfarad capacitor, and that is on the positive 15 volt rail. So it's not on our minus 15 volt rail, which is where we saw the lower resistance. And again, that's not necessarily saying that there's a problem in the minus 15 volt power supply, but it's just something to note that's different. And for completeness, we'll look at the underside. So this module here is actually it's actually a double-sided assembly, and this is the underside. Now it's obviously not as populated as the top, but we can have a look at some of these other boards here, just see some of the construction here. I've already taken a look at here because I'm looking at possibly replacing all of the tantalums on the top side board, and I don't see any of the suspicious. The yellow tantalum capacitors like we've had other problems with on the other boards. I don't see any on these boards. Now I think these are also tantalum electrolytes, but I think these tend to be more reliable than the yellow ones. So I haven't found any of these to be have any problems. So I'm gonna not do anything with those right now. But yeah, this side looks pretty good. I don't see any obvious problems. Obviously, too, and this is one of those things. If you don't want to just go tearing into something just because, if we don't have to, then we're not going to disturb this layout here. But just to have a look, take the car off and look, and just sort of appreciate the construction of this this unit. All right, so in order to replace these tantalum caps here on this board, we're gonna have to take the board out of the cast box here that it's in, and there's a bunch of screws that have to come out all around this board here. So I take all those screws out. I'll have to disconnect the BNC connector here and take this connector, the nut off the front case here, and then there's a jumper wire under this block that just unplugs, and then these two wires here will these pins come out like that, so that'll make those easier to get this board off. So no, don't have to unsolder those. And then the same thing under this block here. There's a little jumper wire that goes here, and it goes into a connector to the board on the underside, so that'll come out. And we'll get the board out, and then we'll look at the tantalums. All these, I'm just going to replace them all because this one here is burned up. So I'm just going to replace. I've got tantalums to replace all of the tantalum caps on this board here. All right, and as you can see, the board is now out of the casting box, and there's a little there's like a cobweb or something in there. So something found a little nest inside this thing. But yeah, as you can see, and there's quite a pile of screws here. And this BNC, these just unthread from the front panel here, which gives me time to look, because I'm gonna see, I've got a couple of BNC connectors. I'm gonna try and see if I can find one to fit, because as it turns out, this type of BNC connector is very difficult to find. I've done quite a bit of scouring the internet trying to find something to source, somewhere to get these BNC, and I haven't found any place to get a BNC connector like this, short of buying a whole nother spectrum analyzer just to rob the connector from the front end, which would be a huge waste of money. So I'm not going to do that, but I'm going to see if I can find. I've got a couple of different connectors I'm going to try and fit, and see if I can find something to fit that will replace this. We'll look at that later. But so the first thing we're going to do is take a look at this board, and I'm going to move this. Box out of the way here, so we can see our board here, and it's a pretty nice board. It's very flimsy with all of the cutouts here, but yeah, it looks like it's nice and clean. Have to that's where the little spider's nest was right there. I'll have to clean that up, but that won't be too big a deal. But anyway, the next thing we're going to do is I'm going to desolder and replace all of these yellow tantalum capacitors here, replace this one that's burned up. I've got replacement parts for all of these tantalums, so that's what I'm going to do next. Replace those, and then take a look, after we get that done, take a look at some options for replacing this BNC connector. All right, all of the tantalums have been replaced now. So you can see there's quite another pile of tantalums. Here's the one that was damaged, and you can see it came off in 2 pieces, so it wasn't even a complete capacitor anymore. Here's that little pin I was talking about that's under there's a little it's like a plastic or Teflon cover, and it just goes into that pin socket right there. But like I said, all the capacitors, all these tantalums have been replaced now. And there's others kind of scattered out throughout here. And I went ahead and cleaned the board up from any kind of flux residue on there. You know, so, I know some of this board, especially like this portion here, looks like a real high impedance junction there. So just trying to, when you're if you're going to do this and you're handling these boards, you know, I always kind of just handle them from the very edges and try to not to touch any of the components, because you don't want to get body oils and whatnot onto the board, which, you know, could affect, you know, could have an effect as far as putting, you know, a high resistance path in there, and especially like on a high impedance section, that could cause some issues. So, you know, just want to kind of handle these boards carefully and not touch stuff that you don't need to touch. But yeah, so it's all cleaned up now, and we can look at the underside here. I cleaned up down there where the that little spider had gotten into the board there and made a little nest. And here's our BNC connector. So as you see, it's it attaches to the board there. And what I'm going to do is I'm going to take this off, and we'll have a look at this connection here. All right, so I've taken this BNC off here. There's 2 screws that, and there's this little, it's like a brass plate that goes under the bottom side here, and here's our BNC connector. And as you can see, it's banged up pretty good, and it's very difficult to get a connector on and off of that. So what I've got is I've got 2 BNC connectors. This first one here that I've got is this BNC connector here, and this is the closest I could find. This is an HP part number 1250-524, which is not the piece here. I think this is, and this has got a I believe it's a Specialty Connectors brand. It's a 28JR308-1, and the HP part number for this is an HP 1250-1596, and I haven't had a whole lot of luck finding one of these. This is the closest thing I could find, and as you can see, the holes here for mounting this are not going to line up with the holes that are on the circuit board. And it's also, if you look at the length here, I'll try to line them up. This is the original one here. It's a little bit longer, so I don't know if I don't think that'll be so much of an issue, but I guess anyway, I got this one, and it wasn't really expensive, so I just went ahead and bought it on the off chance. But as it turns out, it's not going to fit on this board. So the other option here is I've got this is a Pasternak brand. I guess try to dump it out. All right, so the other option here is this is a Pasternak brand BNC connector, and it's one of these kind that you feed the coax into the back of it, and it's a compression fit there. That's the compression nut. But what I thought I might do is see if it will fit inside the chassis, and then I can run a short piece of coax down into where this wire here. I'll have to unsolder and remove this, and I could solder the coax there and solder the braid probably into one of these holes, because these are plated through holes, so they should be able to solder into, and I think that might work. The only thing I don't know is if this nut is too big for the case, so I have to trial fit this in there. So what I'm going to do is we'll set this board back into the the metal case and see if this will fit. It's also if you just compare the size, this other one's also a little bit shorter than the original one, but the I think it'll be okay. It'll just stick a little bit shorter out from the front of the cases. If you look at when it's mounted in here, the front panel, the back of the front panel just comes up to this where it starts to widen out here for the threaded portions, and that part looks to be about the same length, so I think it'll fit. But anyway, we'll see if it will fit, if this back part will fit inside first. All right, I've gone ahead and put this, this is that Pasternak coaxial connector here. I've gone ahead and put it in to the chassis to see if it will fit. And what I'm going to do is I'm going to take this box and I'm going to put it back up into the spectrum analyzer just to see what kind of clearance we get here on the front. Just holding it in here into the spectrum analyzer, and we can see from the front that it looks like it's a pretty good, it'll be sufficient clearance. I mean, you know, I'll be able to get I think I'll be able to get a connector on there. Shouldn't be too big a problem, you know, on there like that. So I think that'll work. Now the question is, when we put the board, there's the board there, put it back into the casting, we'll see how that will fit. And we'll also need to go ahead, and what I'm going to do is I'm going to go ahead and terminate, or not terminate, but I'm going to go ahead and put a coax cable into there and see what kind of clearance we're talking about, because there's not a lot of clearance on the inside here where the board is. So we'll see if that will work. All right, and so I went ahead and put the coax in. This is some RG 316 that I have, coax that will fit this BNC connector. And yeah, it's obviously way too long. I have to trim it down because, as you can see from here, that the this wire here is where the connection needs to go from this cable. So this cable is going to be pretty short to get into that connection there, and then the ground connection here. Now the problem I'm having is, so it fits okay here. This fits fine, and we did the fit test with the front panel to make sure that we had enough clearance, and we had plenty of clearance on the front end. But as you can see, I've got the board in here now. I'm gonna pull it back and see. I'm gonna try to get a hold of it and pull it, sort of slide it back a little bit here. But there we go. Sort of set it up here. And the problem here is that there's not enough clearance down here. This edge of the board needs to sit flush against the wall of this enclosure here, and unfortunately the back nut of this BNC connector is too wide, so it wants to push the board underneath, and it bends the board down, and I don't want to stress the board like that. So if we're going to use this connector, there's really only two options. Either option A, we'd have to cut this board, and it looks like probably cut about the middle of these mounting holes here, and we could probably nibble off some right there. And I looked on the bottom of the board. All right, so the bottom of the board here, and I moved that other connector out of the way. But as you can see, there's nothing on the bottom here. And this is only a this looks to be just a 2-layer board, so it doesn't look like there's any, and I don't imagine there's any other traces under there. If we wanted to cut the board, as you can see there's some light coming through there, so it doesn't look like there's any other traces there except for that ground plane, which is on top. But the ground plane here would be sufficient to cut this part out. But I'm not really crazy about that because, for one thing, I don't really want to mess with this board. And number two, usually when I make modifications things like this, I want them to be reversible. So if I cut the board here, then this would no longer be a reversible modification if I ever do happen to come across one of these BNC connectors again. Then it would be just a simple matter of swapping the parts out. So that option doesn't seem like a very good option. The other option is, and what I'm gonna do is I'm gonna get another, because I've actually got 4 of these connectors, so I'll get another one. I'll take a look at that. All right, so the other option is, here's another, this is the exact same connector, it's just a different one. The other option is to see if it's possible to cut the flange short down here, so that essentially cut this straight across, to see if that would be enough to get the board out of the way. I'm going to go and see how difficult this feels. Like pretty hard, but if the data sheet says it's just nickel-plated brass, so if it's just got brass underneath, it should be pretty soft metal. I'm going to try that and see how that works. So we'll check that and get back to that. All right, and here is the connector. So you can see how filed down. I just used a metal file to file down the one side of the connector body to take a big portion of that flange off. And so I'm going to put it into the enclosure now, and then we'll see if the board will fit. So that's pretty much the most I'm going to be able to take off. So hopefully that will be enough. And we'll put it in with that flange side down, and this nut, which this is the nut from the original connector. It's the same thread size, and so it just fits on this new connector body. So I'm just going to hand tighten that, and then we'll slide the board in. And it looks like it fits. I'm going to try to flip this up here. So it looks like it fits in just about perfect. I think that That's all we can take off, and it's just enough to get it to fit. So now what we need to figure out is how. So this is what I'm going to do is I'm going to take the inner portion off of this connector and reinstall it into this connector here, which is the one that's shaped for the board. All right, so fool on me, but once you put these connectors in like this, they don't want to come out. So I just went ahead and used the parts for this connector and just put a new piece of coax in. So we've got our coax now, and our BNC, we can look at it here, is trimmed down. So that will go into the spectrum analyzer case. Here's the connector in case anyone's interested. It's a Pasternak, and it is a PE4319 is the connector that I'm using here. And they got a pretty good guide here. It tells you how to put the cable in. Works pretty much just like it says here. The one thing to note, this is the little Teflon insert that it talks about here. It says insert PTFE before contact. So you put this little white PTFE washer in there, and it is, where is it at? Somewhere anyway. There's the contactor there. There it is right there. So that little white PTFE little bead looking thing that it talks about, that goes in over the center conductor there after you put the braid out around the compression washer here. And you put that little bead over after you so what it does is you strip the inner conductor, and then this slides over the inner conductor insulation jacket, and the inner conductor, the actual metal part sticks through here, and then you just tin that and then solder on the center conductor, that little gold piece there, and you know, it comes out through the front there like that. So pretty easy to put together. And then there's a little rubber washer. I'll have to slide that back on there. But anyway, so I'm going to put this, actually what I'm going to do is I'm going to strip this down pretty close. I'll probably strip it down about to right there, and then I'll leave a nice long piece of braid that I can use to solder into the circuit board, and then solder the center conductor into the spot where the little wired terminal is on there. So we'll look at that next. So we put the new BNC in, made the solder connection down there for the input of the coax, and I used the one of those screw holes for soldering in the outer jacket there. So what I'm going to do is we'll put it back together. I got to put all the screws in, and remember to put in this flat cable here. I've forgotten to put that in before, and you don't want to calibrate unless that's put in. So I'm going to put this back together, and we'll power on the spectrum analyzer, and we'll see how it's working. I know that you know, this is a low frequency spectrum analyzer. It only goes to 40 megahertz. But I do know that you know, this does change the input somewhat. I don't know if it's going to be a big deal. I mean, you know that this is the 1 megohm input, which is the high impedance input, and it's got this long piece of coax that goes back to here. So this is the low 50 ohm, 75 ohm. This is the low impedance input. So hopefully it won't change anything too significantly. It won't change the noise or the sensitivity. That will have to be determined. I'll have to run the analyzer through through all the calibration checks from the manual and see as long as make sure they're working. Now, I ran the instrument through the all of the basic essentially their confidence checks, and everything passed on all the confidence checks that are listed in the front of the troubleshooting manual. But I have not run it through the calibration check, so I'll have to do that because now that I'm able to actually put an input into the 50 ohm input section, so I'll be able to check that. And then as you can see here, the BNCs are a little bit different in length, but I think that'll be okay. All right, so I'm gonna put it all back together, and then we'll turn the unit on and see how it looks. All right, here we are back with the spectrum analyzer powered up now. As you can see on the display here, I've got it selected right now to the 50 ohms input, and with the new connector here, it makes it much easier to actually. It's usable now. It was just about unusable before with that other connector in there, but now we can use the 50 ohm 75 ohm input here, and I've got it selected to the 50 ohm input, and all I'm doing is supplying a 39 megahertz signal from the signal generator here at so minus 80 dBm, and we can see that got it here on the display. So the amplitude, the marker here showing right here at 39 megahertz, it's showing minus 81 minus 81.5 dB. So it's a little bit of loss in the cable there. Cable's fairly long. It's probably about 4 foot long. Just a piece of RG58 coax. But other than that, it looks pretty good. I don't see anything abnormal. The noise floor looks normal, so we haven't introduced any additional noise into the front end of the 50 ohm low impedance front end of the spectrum analyzer, and the signal here is showing good, showing a correct amplitude, and we can let's see, change this down to 39 megahertz, and we can change our frequency span. We'll zoom right in on that signal there, and we can see it's we've got a pretty tight span here, 250 kilohertz, and a center frequency of 39 megahertz. We can see there is our signal right there, and we can go down adjust the resolution bandwidth down here. That's a little bit too low. We'll keep about 300 hertz there. Otherwise, it'll take forever to sweep. But yeah, it looks like looks like a really good signal right there. Go into a tighter span there. But yeah, I think this is seems to be working pretty good. So, let's go ahead and put this back to preset there. So yeah, it looks pretty good to me. There's our signal there again, picked up the automatic. There's our signal right there. So yeah, it looks pretty good. And now we have a usable low impedance input, and it looks pretty good. It's I guess if anything, it's a little bit crooked there. It's just the way the BNC was put together. But other than that, I think it turned out pretty good. And more importantly, now you can actually use this input. So I think we're going to call this video complete. Now we've got the spectrum analyzer working. I have not, I didn't run through the all of the calibration checks. I just did just a quick check. Didn't see any obvious problems. I'm sure I'll probably go through and run them all some other time, but it's pretty long and pretty boring, so it's not. I'm not going to do it on the video here. But let me know if you like the video and leave any comments you have, and that will finish up this video for now. If you like the channel, just check by every now and then. I've got some more new videos coming out, some more new projects I'm working on, and we'll put those up as I get time to put some videos out. But that's all for this video. Thank you for watching. Goodbye.